the topic which, okay, this is the most important topic nowadays because of global warming. If you see here, the first thing here, the major junk because of global warming is building operation and building material and construction. Okay, and another one is industry, transportation, others. So basically, today we are going to focus only on building operation and building construction material, all those things. So, like if you see, the main purpose to design a green building in which what we can say less power consumption should be there, so that CO2 release should be less, like carbon dioxide emission should be less. In fact, nowadays the trend is going on net zero carbon emission. Okay, so we are going to that part. So to understand that concept, okay, let us go one by one. So first thing, the main purpose of energy simulation is to design green building which will be energy efficient, cost saving, environmental impact of energy use. So we are talking about energy. Okay, imagine a simple thing. We have incandescent bulb and we have LED bulb. So in LED bulb, we can save a lot of energy. But to understand that LED bulb, we should know in a day how many hours it is working, and in a month how many hours it will work. Okay, how many days it will work in a month, and overall in a year how much it is going to be do power consumption. So that calculation need to be done. I'm just saying a small bulb. Okay, but I'm talking about complete centralized air conditioning system and all those things. So and then how we can implement another factors to save the energy. If you see here, we have first thing, a green building is the one which use less water, optimize energy efficiency. So I'm just trying to highlight energy efficiency because the topic is about energy efficiency. Okay, so a green building it conserve natural resources, generate less water, less waste, and provide healthier space for occupants as compared to conventional building. Okay, now the most important thing, imagine if you are going to purchase any building like a flat. So might be same building if the flat is like IGBC rating, Indian Green Building Council, or USGCBC, that is LEED. Okay, these are the bodies which says how is energy saving. Okay, we have different ratings for this one. So I'm just trying to say, imagine if this building is conventional building and another building is green building. So the flat, if it is, imagine normal building, if it is 1 CR, and so that will be around 1.5 CR. Even the value also will be increased just to bring some green building ratings. Okay. So here in India, we have Indian Green Building Council. Okay. And in US and international, we have leadership in energy and environmental design. That is LEED certified. So the building should be IGBC certified in India, or else it should be LEED certified. Okay, so in Gulf, the projects what we are doing is based on the LEED. Okay, and they have their own standard also. But end of the day, we follow this USGCBC. Even IGBC also follows USGBC. So we have exams for this one. I mean, to get pass, we should know the IGBC exam we should write on, or LEED exam we should write on. LEED Green Associate, LEED BD plus C, different exams are there. Okay, but I had seen many of them, they write the exam. After exam, what to do? Okay, that is the thing actually. So this is what we are learning today. Okay, once you pass the exam, or else even it's not mandatory that you should clear the exam. Okay, you should know about this one, that is the main purpose. So I had seen we have trained many students, okay, to prepare for the exam and they got the pass. But after that, what? Okay, just to keep the certificate and show in LinkedIn. Okay, many of people they do like that, but it's not like that. Okay, some of them they work in industry where they can save the energy. So here you see, what does it say? We have IGBC and LEED. So these are the categories, site selection and planning. It means we need to select a site in such a way that, okay, the transportation should be less distance to bring the material. Okay, it's just like I'm giving a small hint. And water conservation, we can use gray water system. Okay, rainwater harvesting, similar to or flushing system, which can we can reuse system, sewage treatment plant. And then we have innovation design process. We can invent from our side some of the radiant cooling, earth air tunnel, and here we have indoor environmental quality. okay, and occupational health, like indoor temperature we need to maintain. Then material conservation, which type of material we are using in building industry. Like, you know, in Hyderabad we have a green building, okay, Godrej green building. So they use the brickwork of ash material, which is made up of, okay, which have less heat transfer, and also it is very good. And now energy conservation. Now this energy conservation we'll talk. So similarly, we have lead, okay, similar to IGBC, you can see all these things. Now, if you try to observe here, in IGBC, we have ratings. Okay, I mean, to get the certification of Indian Green Building Council, we should have 51 to 60 points. Okay, similar silver is there, gold is there, and platinum. This is the points which should achieve. Okay, and same thing here, to get the lead certification, we should have the points 40 to 49, okay, up to 80 plus point earns. So now, how does we get these points? Okay, how does we get the points? So see, just now I had explained you about this one. Okay, these are the categories. So each categories has certain points, like you can see here. Okay, credit points for green building rating system. This is for IGBC and this is for USGCBC. So for site selection, let us talk about IGBC, for example. Okay, for site selection, planning and design. Okay, we need to go with 18 points, maximum 18 points is there. And water efficiency 18 points, energy efficiency 28 points. Okay, now similar to this we have different points. If you try to observe here, the in even in USGCBC, the major percentage of points is in energy efficiency. Okay, I mean, here if you see, like if you get 51 to 60 points, you get certified. So just if you get 28 points here itself, you will get so many points in energy efficiency. So we can work less in another part. Okay, now to do this, we need to know how does we get the points. I mean, first we understand, okay, certification points, and then we gone more inside, and then we split the points. Now again, to get the 28%, what should we do? To get the 30%, what should we do? So for this, we have this one. See here, okay, and this point here. We have base case and proposed case. Now, what is base case and proposed case? Base case means we design as per some standards, which is known as ASHRAE standards, American Society of Heating, Refrigeration, Air Conditioning Engineers. Okay, this is the ASHRAE standard. Now, based on this standard, for example, I design energy saving 6833 kilowatt hour in a year. Okay, I mean, I have done complete energy calculation, and then I got this answer. Now, after this, I implement some innovation, and what innovation, that part we will learn again in few minutes. So proposed case, I got 5506 kilowatt hour. Okay, so how much I am saving? We have a formula: base case minus design case divided by base case into 100. So see, base case, we got this one, and proposed case. So how much we are saving? 20%. Now, what does this table say? If you are saving, for example, okay, 20%, so we get 9 points. Okay, and similar to this, if you are saving more percentage, okay, we are getting more points. So here we understand that these points which I am saying you, okay, these points, okay, we get based on the reduction of energy saving, but it should be uh, considered with base case. So base case itself it's a big challenge actually, because we design base case based on the ASHRAE 90.1. Okay, so this says so many factors. So other than this, we need to go with proposed case. Okay, now if you see another part, here we have this one. Okay, in energy modeling, like now I will show you the software in just few minutes. We have building geometry, weather condition, HVAC system, internal loads. Okay, now what does it say? So if you see in a simulation software, we put inputs, we do simulation, and then we get output. The inputs are weather data, building geometry, building envelope, HVAC system, lighting, cost data. So based on this, we do here load calculation, system simulation, building simulation, economic cost analysis. Then we get the output, building loads, energy requirement for HVAC system, energy requirement of building, life cycle cost. Okay, this is what. Now you see, let us talk about this one. Once we talk about this one, then I will open the software. Otherwise, you might get confusing. Okay, what is software content? So software contains all these things. Okay, we will talk about this. So you can see here we have like first thing, okay, weather data. Now what is weather data? Okay, if you try to observe here, okay, in weather data, we should know the temperature from January to December. Usually in HVAC system, we design based on peak load. Peak load means maximum temperature, I'm saying. Okay. Imagine outside temperature in Hyderabad, it goes up to 42, 46. Okay. So based on that peak temperature, that is appear in May, April or May, we do the selection of air conditioning. But to know the power consumption in each month, we should know the temperature for each month. Like here you can see January to December, we have different temperature. So this is what we go here with weather data. Okay. Then here we have certain standards. Okay, like ECBC standard is the Energy Conservation Building Code. So that standard, it says about, okay, which type of climate zone we are located. So you see Bangalore, it is in temperate. Fine. So now second one is about building geometry. So this is, we should know the weather data. Okay. Now next one is about building geometry. So building geometry means we need to draw the building geometry. Now you see here, let me show you. Here we got this software. Okay. Okay. Here we got this software. Once again. Here we got this software. You can see this is the software. Okay. So this is building geometry. So in this one example, if you see, we have, okay, in this, let us see opening. I'm just saying opening. Now wall window ratio. Okay, I put here 30%. And then I go to layout. So you can see here, this is we got wall window ratio. Okay. So these are the glasses. Now same thing. Okay, in if you see visualize, we see like this. So imagine I want to change here this one, opening approximate 50%, for example. Okay, or let us go with 60%. So in this layout, you can see that this is changed. It means there are certain standard which we need to follow, and then we can do the building geometry. So we should know proper height, width, length, and zones, proper zones. Okay. So this is what we do building geometry. Recently, like we had given this session in some of the colleges also. Okay. And now you can see here what we do, the orientation here, it is showing north orientation. Here you see this is what. Now, when we design, we turn this building in four orientation, like 0 degree, 90 degree, 180 to 70. And then we get the average of this one. So based on that, we do the calculation. I mean, sun rises from east, sets at west. Okay, so that's why we orient the building in different directions to get uh, actual power consumption. Okay, then we have building envelope. So what we discussed so far, we discussed first one weather data, and another one is about building geometry. Next one is building envelope. So building envelope means we have to select proper construction, okay, material. We have to select proper construction material. So we have fenestration, opaque construction, daylighting, building envelope sealing, overhang. Now fenestration means these are the glasses, okay, about the fenestration. So in which light transfer. So we have to select proper glass. Okay, this is what we have a glass. So in this, the light should transfer more, but heat should not transfer more. So that is about fenestration. Okay. Then we have VLT, visible light transmission. That is, okay, we design VLT based on certain standards. Okay, usually we go with 0.7%. That is 70%. Okay, next one, if you see here, we got another one, that is opaque construction. Opaque construction means from which light is not passing. But we need to select proper material, brickwork, roof slab, okay, green roof, all those things. So this is about opaque construction. You can see here, This is solar reflectance, thermal emittance. Okay. Then we have daylighting. Next one. What is daylighting? Daylighting means we need to design daylighting so that the light should be more, okay, in a daytime, so that artificial lights which we are using, that can be off, so we can use natural light. So that is about daylighting system. Okay, then we have building envelope ceiling. What is building envelope ceiling means? We have to make sure that the building should be crack free. I mean, there should be no infiltration. If you see, the air might become inside the building, which is hot air. Okay, so because of that, the load will increase. So that's why building envelope ceiling is required properly. Then overhang, like if you see any proper buildings, okay, we can see in high-rise building or in Hyderabad or in Bangalore, okay, we have overhang or we have side winch, okay, like this. So this also saves a lot of energy. Okay, then we got lighting control. Now, what is lighting control? It's very simple. Space control. Okay, imagine if someone is not there, automatically it will switch off. If someone is there, it will switch on. This is what about automatic lighting sensor. Okay, and then space lighting control. So imagine outside daylight is there. Okay, then in that case, this light will switch off or it will change its lux, or I can say brightness. Okay, based on outside. So this is about space lighting control. Then we got another one, day lighting control. Okay, so imagine if complete light is coming and then you can see a 20%, 70%. Okay, exterior lighting control is also about getting the power consumption. Okay, like saving the power consumption by solar panels. Okay, anything to ask here? Queries and correct. Okay, so fine. So this is about exterior lighting control. Okay, now next one, night purge ventilation. So this is night purge ventilation is about what I can say. What imagine if uh, in summer season, okay, in daytime this is completely off. In night time we open the windows so that uh, the heat moves outside. This is about night purge ventilation. Okay, this is about night purge ventilation. So we designed this one. This is what it says. You see, and then we have a wind tower. What is this wind tower? Okay, wind tower means, okay, we use a fan. Okay, from this you can see this is fan and hot air comes here. Fine. Then we spray the water in this tower. So this hot air touches to the water and then it comes inside the building. See, this is what we have written. Now this goes outside. So in fact, indirectly we are trying to cool the building by the process. So this process is known as wind tower. Okay, then earth air tunnel. And this one, like if you see, if you take a fan, okay, and then we have a ducting inside the earth. So this is approximate 3 meter. So if you go 3 meter inside, the temperature will be lower. Okay, so in fact, in Hyderabad itself, we have done a project also. In that project, what we did, okay, we have done this earth air tunnel concept. Other than that, we use here desert cooler also. That is, in our home, we used to have air cooler, okay, from which we spray the water through the nozzles, right? Like mesh होता है, okay, जिसमें से हम पूरा पानी spray होता है. So that is desert cooler, air cooler. So that we have used. So in this case, we are cooling the air from outside also, and then when the air goes inside, again it gets cooled. So in fact, double time we are cooling the air and we are sending to the building. Okay, so this is earth air tunnel concept. Then we have solar water heating. So nowadays, this is a common thing in all the hotels. Okay, even in Bangalore, I had seen that they use the solar water heating. That is solar panels. Okay, solar panels. Only the disadvantage with this one is okay, in they only use solar water heater. They don't use electrical heater. So the disadvantage in case if solar heat is not available, like clouds are there. So this cannot be get heated up. It cannot be charged. So we get cool water only. So in fact, it should also be provided heating from another heat source. So it has certain percentage, okay, to design this one. Then, okay, so this is about, like, what I had explained you so far is about the overview of the inputs which we provide in building energy simulation software. Now I will open the software. Before we open the software, okay, let us see what is building energy modeling. Okay, so building energy simulation, also called as building energy modeling or energy modeling in context, is the use of software to predict the energy use of building. Okay, in addition to energy units, most software includes utility rate inputs and can predict energy cost. It also used to evaluate the payback of green energy solution like solar panels and photovoltaic, wind turbine, and high efficiency appliances. Okay, so here predict the monthly energy consumption and bills, predict the annual energy cost, annual CO2 emission, compare the contrast difference between efficiency options, determine the life cycle payback on various options. Okay, like we can save that. So we use these different softwares. We have Energy Plus, Design Builder, eQuest, and OpenStudio. Okay, now let us see the software very quick. So here I will just show you a small example. Okay. So here I have changed, for example, this is about the software. Okay, that is Design Builder software. So what we do, the main thing we do simulation here. You see, this is simulation. Now when we select this simulation and we can update this data. So now let us do, you see, this is January to 31st. Okay, December overall year. So when I do, here we are getting the results. So if you got big project, it will take time. I'll just show you how to check this result. Okay, so let us understand this one. In this, we can select fuel totals. Okay, and then fuel total means total how much fuel it is consuming. And then this one as current period overall year. Okay, and this you can see graph and table. So this is graph. So if I do fuel breakdown, so here we can see we got this one lighting room. Okay, and then this is about run period. Okay, this is monthly. So you can see here electricity, lighting. Okay, in January, February, March, how much it is consuming. Each and everything it is showing. Fine. So total power consumption, if you want to see, okay, we go with fuel breakdown. And then imagine if I go here with grids. So this is what we get here, electricity. You can see this is monthly. Okay, January to December, electrical consumption. And then yearly means run period. So you see, we have around 8063 kilowatt. So if I do now, what I need to do to design this one, I have to come here. I'm just giving the overview here. We have certain options like activity, for example. In this, we have different templates like office is there. Imagine instead of office, you are having a school building or something else. So here we get all the options. Okay, this is about education. Okay, and then we have all lecture, theater, sports, teaching areas. So once we select, here the template will change. Now you see everything is changed based on this template. Now we got all these options: heating, setback, okay, holidays, lighting system. Okay, these are the inputs which we need to give, like minimum pressure is there. Okay, how much liter per second per person, and then we have velocity clothing. Okay, this is also winter clothing, summer clothing. All these things is given. Next one, if you see, we got construction. Construction is about type of material which we use. Example, if I use this one, so this is my construction. Okay, which brick I'm going to use, which material I'm going to use. Okay, this is about construction. So you see, external wall example. I want to change the external wall properties. I can come here. I can change this one. So this is what, if you see, for example, if you see edit data, then in this we have all the values. So the most important thing here is about U value calculator. That is overall heat transfer coefficient. The people who are from, I mean, building industry, they know about this. And this is about heat transfer. I mean, if U value is more, heat transfer is more. If U value is less, heat transfer is less. We have a formula. Q is equal to UA delta T. Okay. Based on that formula, we get this one. So here we have this thing. Next one, if you see, for example, openings. Now in openings, I have shading, imagine. So window shading I'm giving. Okay, and we have like this is about type. Okay, so if you see the inside, outside, this is we get here different. Okay, local shading we can give. Overhang is there. Okay, so this is when I show in layout. You can see, for example, when you open layout, you see we got overhang. Previously it was not there. Remember? Now let us go in opening. So we have certain standard wall window ratio. Okay, it is about 30% as per standard. So instead of 1 meter, if you give, for example, here, we can change this one to 1.5 meter or 2 meter overhang. Okay, now after this lighting system. In lighting system, like how much light is required. Okay, that is watts per meter square, 100 lux. And then we have HVAC system. That centralized air conditioning, we can do a lot of things here. Okay, we have an option. Okay, that you can change the model option to detail HVAC. Example, when I select this one, I got HVAC system. When I select detail, I will get HVAC system itself. Okay, here you see we got HVAC block. In this HVAC block, we can analyze the air conditioning system. Right? Click here. Okay, this is we got here. So we air cooled chiller example. I'm selecting finish. So we added up here. Um, this is centralized air conditioning. Now this is chiller, pump. So for each, I'm just coming here. Let's maximize this one. Okay, here we have. Okay, this if you see, I'm selecting this one. So each and everything, I'm just showing you one example. When I select edit component, I can provide here all the values of that chiller related to chiller. Okay, what is coefficient of performance and all other factors, right? So this is one thing. Next one, I was explaining you about here in building. Okay, you see we got here 2 meter. It was previously 1.5 and windows also get less. So HVAC, now here we got template. We can change this one if you want. Then so far we can do, and then we can do the simulation. Okay, after changing something. If I come here and I do simulation, let us just update the data very quick. We added here airport chiller on. So I mean this process is very long. It's like R&D. Okay, we have to do multiple times, and we need to get the details. Okay, we need to change one parameter and try to check for all other parameters. Okay, this is what we say. I'm just trying. I modified something. I'm trying to see what will be the result. So this was the short discussion about I mean energy simulation and like building energy modeling related to mechanical and other factors. Yeah. Okay. Here you see electricity is increased. Okay, it was 8,000. Remember, now it has become 25,000. The reason is that we added up here what all HVAC system. Okay, that's the reason. So this is what about uh, building energy system. If you have any question, you can ask. सहब भाई आप कुछ बोलना चाह रहे हैं? Another people, if they have any doubts, they can unmute and they can ask. Abdullah, Afroz, Abdul Rashid.
Hi, this is Suraj here.
Yes.
Yeah, sorry if my question is not a little silly because I'm not from this field at all. But I just want to know if these kind of certifications what you showed, like LEED and ISBC, are they mandatorily used when the architectures are built for the buildings and everything, or is it just a recommendation?
Recommendation, not mandatory.
Okay, because you showed some certificate from the government of India also and at an international level. So I
Yes.
thought probably the architects whom we approach for any kind of building material and everything before we start to build something, I mean, be it a commercial building or a residential or whatever. So do they follow this as a mandate or they just design it from their
No, no,
experience?
no. Suppose if they need certification, so what we will do, what they will do, they will design green building and they will call to the third party, that is energy audit people. So they will come to
Okay.
that building and they will analyze that what actually they are doing correct or wrong. Then only they get the certification. I mean, not exam I'm saying, building certification I'm saying.
Okay. So you want to say if we need this kind of energy efficient buildings, only then we approach the architects and they design it according to these recommendations. It's
Yes.
not a mandate from anybody at all.
Not mandatory, but if you like, for example, if you want to increase the value of a building, okay,
Uh-huh.
cost wise, as well as if you want to save the energy also, run period overall year, if
Correct,
you want to
correct.
pay
Yeah.
back, then a third we have to design, but third
Mm-hmm.
party will come, IGBC people, and they will check whether
Okay.
they are doing correct, and then they put stamp, then only we will get the certificate.
Okay. Okay. Yeah. Thank you.
Pleasure. Any other questions? So might be here, many of them are there not related to this field. Okay. Uh, because it was said in short time period. So anyhow, like if you need any help regarding mechanical engineering side or civil engineering or architecture engineering side, electrical engineering side, we are always there to help you. Okay, so like here, just you can note down my number if you want. Okay, so that you can share with someone if they need any help. We are located in Bangalore also. Okay, so there is Abdul Majeed. My name is Abdul Majeed. This is what you can uh, share, and you can we can guide for the freshers. Like there are so many freshers 2024 pass out mechanical engineers. Okay, so they are coming to us. So they want to learn core engineering, mechanical side only. So we can help out them. I mean, if they want to be only in mechanical or civil side, they don't want to go in IT. There are some people like me, for example. Okay, I don't want to go in IT. I want to be in core subject of a mechanical engineering because there are a lot of things with which we can do it. So people are not aware from that one. Okay, so we can guide to them properly. Okay, so I think so. Let's finish the session. Okay, thank you so much, everyone. Okay.
Thank you.
Uh, I have a doubt apart from the yes. What is your doubt? Please ask with me, Muzammil. You can unmute and you can ask if you want.
Assalamu alaikum, sir. Actually, I'm related to QS field, sir. I
Well,
want to know the I want to know the value engineering, sir, because I am a fresher. I want to know the value engineering previous.
You are from which background?
So mechanical only.
Value engineering means what? Uh,
In
Related
QS,
to.
like using value. QS, sir. MEP QS, Conduit Server.
Acha, 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 okay, okay, okay. Actually, that is value engineering is about, for example, if you have done a quantity takeoff for one project, and then we design better project, and then we are getting less quantity takeoff. So the difference between that and this related to power consumption, it is payback period as well as capital cost. That is about value engineering. So for doing that value engineering, you should know proper MEP system. I mean, I had seen many people, they don't understand the MEP system and then they go directly into the quantity takeoff. Okay, so it will be very difficult for them. So I suggest at least they should do, they should understand complete MEP system. How does it work? And then they can do the value engineering properly. I mean, what are the parameters to set to save the energy that they can do. We have done some value engineering in Gulf. I was also involved actually in that.
Thank you, sir.
Okay. Thank you so much, everyone. Okay.
Thank you.
Thank you. Jazakallah khair, Abdul Majeed bhai.
Okay, bye. Take care.
Assalamu alaikum.
Waalaikum salam.